All right, here is the problem. We have a crystal, and we want to decide, is it calcite, quartz, or dolomite, by looking at the density of the crystal. So our objective here is to find the density of the crystal, and we're given some experimental data. All right, we've got the mass, it's 81.3 grams. We drop the crystal into some water. We're going to drop it into 149 milliliters of water, and when the crystal is in the water, it is going to make the water level go up to 179 milliliters. So we can use this data to find the density of the crystal. The density is going to be the mass divided by the volume. All right. Now we know the mass, it's 81.3 grams. How about the volume? Well, the volume is going to be the difference between the water plus the crystal volume and the water volume. Because we need to put the volume of the crystal down here. And both of those are in milliliters, so I can write it down like that. Let's figure out what the actual number is. Now I've got to watch to put parentheses in here if I'm going to type it in this way. I said divided by, and then I'm going to say parentheses 179 minus 149. .71. What about the units? Grams on top, milliliters on the bottom, so it's grams divided by milliliters are the units. All right, now if I didn't know anything about significant figures, I would jump to a conclusion here. I'd say 2.71 grams per milliliter. The density is really close to calcite, so if it has to be one of these three, it's calcite. But now that I know about significant figures, significant digits, I can be a little bit more subtle here. How many significant figures, how many significant digits should I round this off to? All right, well, it's a multi-step calculation that I did here. Step 1 was take that difference, and step 2 was do the division. When I did this difference, the difference there is 30 milliliters, but I have to be very careful about how I write that down, right? Because where's the uncertain figure here? I'm using the rule for addition and subtraction, which says that the last decimal place in your answer is going to be the uncertain place in your weakest link. Now my uncertain place for this one is in the milliliters place, the 1 milliliters place. Here it's in the ones place as well. So my uncertainty is here. And that means really I have two significant figures because I'm uncertain by a milliliter here. So I'm going to write this down by putting a decimal point there, and that's going to ensure that that trailing zero is taken as significant by anybody that's looking at this. All right, that means that I've got two significant figures on the bottom and three significant figures on the top. So how many significant figures should I have here? If you said 2, you're right. I'm going to need to round this off to 2 figures. And my final answer is going to be 2.7 grams per milliliter. That's what I would show someone. All right. So now which one is it? I'm not so confident anymore because my uncertain place is in the tenths place. Now that means that this could be 2.8, this could be 2.6, it could be up or down 1 in the last place there. And notice that I now can't really tell which one of these I've got. So my conclusion with this data is it could be any of the 3 minerals that I have up there, and I really could. It's closest to calcite. I could note that. Looks closest to calcite, but it could be any of the three. Now, how could I fix this? What if I had more significant digits on my volume? Suppose I had 3. I need at least 3 significant figures to make a decision here, because they're all different in the second place. In the third place here, if I knew it out to there, I could distinguish between these. So what if I go back and I redo the experiment, and this time I'm going to be careful to measure the volumes out to the 1/10 of a milliliter instead. So suppose my two volumes were, instead of 149 milliliters, I had 149.0 milliliters. And instead of 179 milliliters, I had measured 179.0 milliliters. Where I'm writing that out to show that I measured to the nearest 1/10 of a milliliter. Now in that case, the difference between the two is going to be 30.0 milliliters. These have the uncertain digit in the 10th place, so my answer will have the uncertain digit in the 10th place here. And now if I do the calculation, I would have had 3 significant figures down here, and I could have kept it out to 3 significant figures here. Now I can kind of clearly see that it is much closer to calcite than it is to any of these others. I am pretty sure about that 10th place, not so sure about the 100th place. So this matches up with calcite, and I could say it's most probably calcite. My conclusion would be different, you see, depending on how many significant figures I have.